Okay, guys, I'm gonna show you something very, 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 very important, and it's really easy to miss. So pay attention, okay? So it's gonna happen so fast. It's gonna be blink in the second. So f of x equal to e to the x, right? E to the x, okay? So what we're gonna do is we're gonna show you the derivative. We already assigned as f of x, and we're gonna take a derivative of this function, and we're gonna graph it, okay? But you guys, I gotta pay attention, so you gotta stay at the board in order to see what happened. Okay, so we're gonna graph f prime of x here. No. Are you guys ready?
No.
Okay, pay attention. You cannot lose track.
That's so fast. That's crazy.
Do you see it?
It's the same thing. It's on top of the. Oh, wow.
That's what I say. It's so fast that you can barely see it, how fast it moves. I'm gonna graph the double derivative of e to the x, right?
Wow. Oh my god.
See?
Crazy mystery.
Magic, right? So it never happened. Never happened with other function. Try any other function. Try sine of x, right? If I try sine of x, that's not gonna happen. It's gonna give you three different graphs right here, and they all f of x, f prime of x, and f double prime of x, huh?
Is it because it's a constant?
No, e to the x is not a constant. It's a function actually.
But he's a constant.
E is a constant, but okay, then how about we say 2 to the x? Is 2 to the x like the same way?
No. How about 0?
Well, 2 to the x. So it's not because of constant, but 2 to the x is actually pretty interesting too, which is you got still three different graphs, but only e are different. So e is a very interesting number. It's called Euler's number. Those of you guys don't know Euler, he's a very famous mathematician. He does some crazy stuff, right? He does some crazy stuff. But 2 to the x didn't work, but only work on the e. If you realize, if I change this to e, guess what? They will go like, boom, same graph. Like magic, right? Okay, so that's not only thing that's crazy though, but this is one of the most interesting. It turns out you already know why. Because if you did yesterday's test, and if you know how to do it very well, you can probably do the same thing, and you can probably establish this proof why that is. Okay, so I'm gonna ask you to prove it. Y is equal to e to the x. I want you to take a derivative without taking derivative e to the x. I want you to take a derivative of this function without taking derivative e to the x. Because we know derivative of e to the x is e to the x, right? So that would be lose the point. Now, how do I do it without it? What did we learn before?
ln both sides.
ln both sides. Can you guys try it? Try to take a derivative of ln both sides and see what happened. Jack, you okay?
You were? Oh god, what? Oh, you found out your score. What'd you get?
Let's just say I didn't do too good on the last history test. Why do you think you did? I gotta rewrite my whole essay.
It was wrong. Easy.
I didn't do ace formula.
Okay, did you guys take a derivative yet?
Is that all? Is it x? All of y equals 1? Oh wait.
Wait. Figuring this out.
What did we learn before? Take a natural log, right? I show you a different color. What happened? When we natural log this, what? Yes, it cancels out. So ln, and this one is e to the x, and this is y, and it cancel out nicely. X, and this is ln of y. Now I'm going to take a derivative of this, right? What happened if I take a derivative of this? What happened to derivative natural log of y? Y prime over y, good. Is equal to what? Derivative of the x is what? 1, right? And the y prime is equal to y. Do you see that?
Yeah.
Y prime is equal to y, which is also known as e to the x. pretty cool, right? It's a very simple proof. It turns out you already knew it, but you didn't know it. You didn't know it, right? So that's why I'm saying taking derivative e to the x without taking derivative e to the x. I should do a TikTok video about that.
I can't believe this one simple trick.
One simple math.
You know what the TikTok they always say is like saying something without saying something. You know what I'm talking about?
Tell me you're a math teacher without telling me you're a math teacher.
Yeah, something like that. So how do you take a derivative e to the x without taking derivative e to the x? So yeah, so that's a very simple trick. Yes.
What's the name of these notes?
Derivative e to the x and integration e to the x. Okay, so now what we're gonna tell you is the derivative of e to the x, you guys already know, is equal to e to the x. Does that make sense? And what is the derivative of e to the u? Well, it turns out there's a chain rule involved when you take a derivative of e to the u. So a little bit more, it's e to the u du dx. You had to take a derivative of the u. Okay? Or eu u prime. You can do that also. So those are the things that you have to pay attention to when you take a derivative. It looks like they are the same, but they are not the same. And I'll show you an example here in a second. If I have d to the dx of e to the 2x, what do you think derivative is? It's pretty easy. Yes, you have to write down the original function, and you have to take a derivative of the 2x, which is 2, right? Which is a chain rule. It turns out the chain rule occur everywhere, and also u substitution occur everywhere, but derivative usually deal with chain rule. Pretty easy, right?
So do you keep multiplying it by 2?
Huh?
The more derivatives you take?
Yes. So you can take technically you can take 10 derivative will be 2 to the 10 power e to the 2x. Technically that will be the same. Now what happened is, can I ask you to find extremas? Remember on your last test, it has a one question says find extrema. And I will say find extrema, right, of y equal to x squared and e to the x, or e to the negative x for that matter. Let's do e to the negative x. That seems more fun. So that means I had to take what? I had to take a derivative, right? Find the critical value, right? Find the zeros. Can you do that?
Then do it. But why did you do e to the negative? No, I don't know what to happen. Do it. How do you find the zero for this?
Did you do product rule? You have to do product rule. Possibly. So if I take a derivative, let's say dy dx, you have, you don't want to do ln on both sides. You want to do product rule here because you have two functions multiply each other. This is the first function. This is the second function. So when you take a derivative of this, Zach, pay attention. Thank you. Okay, take a derivative of x squared is going to give you 2x. And then e to the negative x plus x squared times e to the negative x times negative 1. Do you see that? Chain rule. Don't forget that chain rule.
Explain that, please.
I take a derivative of x squared and e to the negative x as a product rule because they are
Okay.
product of two things.
Explain why the derivative of e to the negative x is e to the negative x times negative 1.
Because the chain rule, e to the u times u prime, right? So this is x squared, and we leave the second term alone, just like this, and we keep the x squared. Xavier, if you want to know, I'm showing you.
Oh.
If I take a derivative of the x squared, it's going to be 2x, and leave this term alone, and then leave this term alone, take a derivative of e to the negative x. Remember, derivative of e to the u means anything other than x. So that means e to the u times u prime. So therefore, e to the negative x times negative 1. Now what we're going to do is, in order for you to factor out, you can factor out e to the negative x. You can factor out an x here, and that's going to be 2 minus x. Does that make sense? Do they both have x? Do they both have e to the negative x? Can I factor out? Now, you got x equal to 0, x equal to 2. There are two things happen. They are probably minimum, maximum. You have to go do number line tests on it, right? So now you're going to say, how come e to the negative x never equal to 0? Well, e to the any number does not give you 0 because the graph is like this way, right? E to the negative number is we go into infinite, it becomes 0. But the problem, infinite is not a real number. Infinite is a number that does not exist. Why is infinite number as a number does not exist? For example, if my house to Tyson's house is infinite long, now it doesn't matter if I drive 10 miles per hour, 100 miles per hour, 1 billion miles per hour, I'm not going to get to Tyson's house. So that means you have to reach negative infinity to get to 0. But that's not real. That's not possible for you to drive there. We can assume that we can drive that far, but that's a kind of like thinking like limits approach. But technically, we cannot get there. It doesn't matter how fast I'm driving because his house is getting further and further away as I'm faster I drive. It's infinite long. Hopefully that makes sense. And you can 0 and 2 here. You can do a number line here. You can say e to the negative x. E to the negative x is always positive. It doesn't matter what, right? And the just only thing that you will change is x and 2 minus x. Okay, so now x equal to 0, x equal to 2. So I'm going to say positive, 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 negative, positive, positive. And if it's negative 1, it's going to be positive. If 1 is going to be positive, this is negative. So it's a negative, positive, negative. So x equal to 0 is a relative min. And x equal to 2 is relative max. Does that make sense? We know how to do this since the last time. Just this time the format is a little bit different. So that's the application of it. That's the application of a derivative. How about this application? How do I take a derivative of this? What kind of derivative I have to do here? They are that Raven rule. Good job. But what's that derivative called when I take a derivative of this? What does that call? Start with the I.
Oh,
Impossible.
Implicit derivative. Right.
But that's the natural log x squared.
Yeah, and well, there's a combination. So the argument has a mixture with the x and y. Okay, see how your time's up. Okay, so actually you got 8 more minutes than it's supposed to be. But anyway. So derivative e to the xy plus natural log of x squared y equal to 3x. Thanks. I need you to turn in. Otherwise, it's not fair for other people. Thank you. Okay, so now let's take a derivative of this. Now, like Derek says, there's chain rule, there's a product rule, and there's logarithms that you can break apart. And there's so many things can happen. So make sure you gotta do things carefully, especially the first one here. If I take a derivative e to the xy, what am I gonna get? E to the u prime. So think about it. E to the u times u prime.
Y dy over x.
Can you say that again?
E to the xy.
Okay, e to the xy, which is that's the derivative of e to the xy, and then there's a u prime, right? Then there's a product rule here. What is the product rule? X dy dx, good. Plus what? Y, good job. And then this one I can break apart too. That's going to be 2 ln of x plus ln of y. Hopefully you see that. And then if I take a derivative of that, it's going to be 2 over x plus dy dx over y equal to 3. Does that make sense? Am I going too fast?
Oh, so you would separate, so it'd be ln x, sorry, it'd be 2 ln x plus ln y.
Yep.
And then you did the derivative?
Yeah.
Okay, so you take the derivative. You don't you separate it via ln x squared.
I'll distribute them. So it'll be x e to the xy dy dx plus y e to the xy plus 2 over x plus dy dx over y equal to 3. Now, anything non-dy dx term, I'm moving on the right-hand side. So 3 minus 2 over x minus y e to the xy. Does that make sense? And then the dy dx term, I'm going to take it out. Dy dx here. I'm going to say x e to the xy plus 1 over y. I think this is what happened. Danielle, are you okay? Okay, now just divide it over. Dy dx is equal to 3 minus 2 over x minus y e to the xy all over x e to the y x plus 1 over y. Now I can always multiply top and bottom to get rid of complex fraction. So I multiply top and bottom by xy. So that's equal to x squared y e to the xy plus x. And this is 3xy minus 2y minus xy squared e to the xy. So this is what happened at the end. Now this one is more complicated than last time because this time has a chain rule of e to the xy.
Monsieur, have you ever heard the term overkill?
Overpowered?
No, overkill.
Overkill?
Yeah.
Oh.
Like what?
Is this what described this? We have not even close to being finished.
You better boss around the answer.
It's working.
We just teach you the derivative. No, we're gonna teach you integration next.
Yeah. You multiply everything by x times y. Is she on the right to get rid of the fraction within the fraction?
I wasn't here. Now I'm out. I'll still get over it in a few months.
What is it?
Makes sense. It doesn't make sense. Yeah. Okay. So that thing
Did now you understand? Oh, good. Today you don't have questions.
all the things that didn't have dy over dx, we subtracted. So like, sorry, this and this don't have dy over dx. We subtracted it and put it there, and then you can factor out the dy over dx on this left side. And you put the what was left in parentheses, and you divided it both sides to get rid of this. So dy over dx equals all of this over this. And he wants to get rid of the fractions within the fractions, and there's an over x here and an over y here, so you multiply both
So what's
top and bottom by x, y.
You take
But it's really about that.
Okay, so now we're gonna go to integrations. So don't get confused between integration and derivative. Today you're gonna get a little bit of both. You're gonna, I will say, integration section, derivative section. Derivative just focus on chain rule, and antiderivative focus on use substitutions. So what's integration e to the x dx?
E to the x.
E to the x plus c. Good job. What's the integration e to the u du? It turns out exactly the same. E to the u plus c. But here's a tricky part. I'm writing red. This is tricky, right? Tricky. How to spell tricky? Tricky, yeah. So it's tricky. Why is it tricky? Because when they have u substitution, there's a du. Okay, so u and du and dx is involved. So you have to make sure it works completely. What I mean by this is, imagine this. Imagine if I just take e to the 2x dx. Now, what do you think the answer is going to be without me teaching you? What do you think the answer is going to be? Integration e to the 2x dx? Watch your language. What do you think integration e to the 2x dx is? 1/2 e to the 2x. That's a great job. That's a good job. Now, what actually happened is this. So I'm going to write in black, so something kind of important. And there's a shortcut to do this. So make sure you understand both. So u equal to 2x. If I do integration, I'm going to do u equal to 2x. This is what actually happened. Now, I used to teach this way. And my student, Sadat, he's like, Mr. Ye, I think you really need to teach student the shortcut instead of doing all this unnecessary writing, because he work very fast. And I say, I'll try it. I'll see if it's more efficient. So what happened is this one is going to change into e to the u, and this one's going to du over 2. Now, you see that over 2 is going to factor out e to the u du. And that's equal to 1/2 e to the 2x plus c. Now, he says that this 2 and this 1/2, they are reciprocal each other when the x is in the first degree. Well, that's always true. That's true, because most of the time I do integration, I do it, use substitution so often that just 1/2 I just pull it in the front and without thinking. So I can actually skip all those methods. I can straight to go here without too much work. Does that make sense? No?
The x is the first degree, so you take the reciprocal into.
Reciprocal is what I want to you saw this on Penable and Rowan.
Yeah.
Now I prefer this way. I prefer this way. Now some people want to do it quicker. Then it's gonna be 1/2 e to the 2x, but it's only applied to the 2 to the x to the first degree, not 2 to the x second, because 2 to the x second, u equal to 2x second, then du is gonna be 4x dx. So therefore there's a 4 in the front as opposed to the 2. Now, this also happened with integration sine of 3x. Well, it turns out it's very easy. U equal to 3x, du equal to 3 dx, du over 3, but again, it's over 3, so it's 1 over 3, negative cosine of 3x. Without any work, I can figure out what's negative 1/3 cosine 3x plus c. I really hope teaching you a shortcut doesn't confuse you. It does? Then just worry about, just do this. Just do it this way.
Yeah.
Just do it this way. Yeah, just do it this way. It'll be much simpler. Now, if you do it like 10 times, you'll see, oh, I understand what you're saying. It doesn't matter if e to the any type of a to the x dx. The answer is always going to be 1 over a e to the ax plus c. It's always going to be that way. Or sine of ax is always going to be 1 over a from the integration rule trick. So it's always going to be true. But this is something that I figure that I'm going to teach. I'm going to try it, listen to his advice, see if it worked better for some students. But of course, only in x to the first degrees. Am I going too fast? No? Okay. Now, how would I take an integration to this?
Take E out of everything.
No, you cannot do that.
Oh,
You kill a kitten when you do that. Try it.
oh, no.
Yeah, so some people says, don't think complex math, think simple, don't think hard. Look, I'm lazy, you're lazy, we all lazy. We're gonna figure out the best way to do things instead of the longest way to do something. Always think simple. Remember, the most beautiful thing is always simple thing. Simple thing is perfect. But to be simple is also sometimes, to knowing what to do is always the best thing. Yes, you can break to pieces using algebra.
What you saying?
Break to pieces using algebra.
Oh. Yeah.
Right.
And then you just have to follow exponential rule.
What? Oh. Three of us. Three of mine. The exponential rule is if you divide.
Remember that exponential rule is a to the m over a to the n equal to a to the n minus n? Yeah. Yeah. It's a basic algebra 1 rule.
It's the long division. It's not long division.
You didn't do long division, do you?
No, I'm just like it's on the person.
No, long division only if bottom is binomial or trinomial. Bottom is monomial, it's always split to pieces. And you split the pieces, you just do individually. So e to the 3x over e to the x minus e to the x over e to the x minus e to the negative 2x over e to the x dx. Now you're going to see this. It's always top minus bottom. So 3x minus x is 2x. Minus what? Minus e to the negative 3x dx. Am I confusing anybody?
Oh, you changed it.
This is just algebra 1 technique. You already know this stuff. Then all you gotta do is using that trick. Remember that trick? This is 2, this is the first degree. Guess what? 1/2 e to the 2x. Minus x. Right? Plus 1 over 3rd e to the negative 3x. Why plus? Because negative, negative, positive. Plus c. Done. Really complex looking problem. Very simple solutions.
See, that one makes sense. Do it after worry about
So a lot of time this can apply to derivative. I can give you a derivative, same thing. Split up, take a derivative, much easier.
this.
It's okay. This is bad, good, understand, don't understand.
It'll be super hard. You have homework, right? You have something.
Yeah, we have one. But it's very easy. Okay, so now this one is a little bit harder, all right? So e to the square root of x over square root of x dx.
Oh, cool.
Okay, so hear me out for a second. Hear me out for a second. Guys, look at me for a second. Because sometimes you have to look at me to make sense. I always said u equal to something, right? I always said u equal to something. And just like you playing chess, like David is playing chess, he's going to think a long time before he make a move. Because he's thinking, am I moving that piece? I'm going to threaten other pieces? Or I'm going to sacrifice my pieces? How am I going to gain tempos? How am I going to do all those things? And that's how chess thinking. So for you, this not just say, oh yeah, u equal to e to the square root of x, and then go ahead and do it, and then you end up get stuck and also get to wrong answer. Think about this. You want to set u equal to something. At the same time, you're going to do the derivative inside your head. Without writing anything down, see if that works first. So remember, u equal to something, usually it says u equal to x squared, du is going to be x, right? One less degree, right? Does that make sense? One less degree. So u is equal to what here? Why? Square root of x, right? That's going to be x to the 1/2. But what's the derivative of x to the 1/2? 1 over 2 x to the negative half. One less degree, right? Now, if I change it, I can say this, 1 over 2 square root x dx. Does that make sense? I'll move it to the other side, and guess what? They are here for you to cancel. I always set u equal to something where you can cancel later for the du. Does that make sense? E to the u, square root of x. Now dx, if I move to the other side, 2 square root of x du equal to dx, then that's going to be 2 square root of x du. How nice. This cancel out perfectly. So always plan something before you make the move. Okay, always plan something. If I u equal to this way, is that gonna help me solve the problem first? Is anything I can cancel? Hopefully. Not everything's a back substitution, Ethan. Ethan, give me that evil look. No, he tried to back up some other questions, but it doesn't work.
No, you were the one trying to back up.
He was trying to back up and.
I was just trying to not back up.
Oh, okay.
Oh yeah, that's true. But backs up work on that particular question. So now there's 2e to the u du, and then that's gonna be 2e to the square root of x dx. Oh, not dx, sorry. It's gonna be plus c, and that's it. If you don't believe me, take a derivative of this. See if it works. We learn how to take a derivative of this. Me too. Okay, so does this make sense? U equal to something that's gonna help you solve the problem. Right? How about e to the 1 over x squared?
Why did you do this today?
It's like a thing here right now.
Oh, never mind. Oh, yes. Negative 1 over x squared.
I literally read the art, and I still got it. I read it. And then the graphics, I got like all my points just today. Like,
Yeah,
Okay, focus on here. We got one problem here.
okay, I think I really don't.
Okay, so I didn't really want to English too. I got B4.
Are you guys done yet?
Okay,
Hold on.
that's good.
Tyson's done. Good.
Let's see.
X to negative 1. Take the root of negative x to negative 2.
Oh, yeah. Yeah.
X to negative 2, whatever. There's a negative right here.
Yeah.
No, I multiplied that.
Oh,
I'm
you-
multiplied.
okay.
Yeah. Oh, yeah. What? Okay, so.
What is u equal to? Do you see that 1 over x is x to the negative 1 degree? What's one lesser degree than that? Negative 2, which is x to the negative 2 is right here, right? It's perfect aligned to each other. So du is equal to negative 1 x to the negative 2 dx. Now I can simplify it like this, and I'm moving to the other side, so x squared negative du equal to dx. So you see that x squared cancel out? Du, sorry. So this cancel out nicely. Negative e to the what? 1 over x plus c. Wow, it's a really hard problem, but it's also not hard.
Wait, are you supposed to do negative e to 1 over x, and then the derivative 1 over x plus c?
Yeah, the only thing that makes that hard is like, it's like all the math, it all makes sense, but like actually thinking about what to do, and like I never would have thought. Like, the X, you know, I'd be thinking of something else that we already did, try and apply that, and it's like, no, I really.
But do you see the pattern that you see this pattern that x to the negative 1 power derivative of this one is going to be negative 2 power,
I see it, yeah.
and negative 2 power is right here. It's would have cancel with this one perfectly.
Miss Kate, you forgot to introduce.
Didn't I agree?
No. It could be negative e to the 1 over x times and then u prime, which is, you know what I mean?
I don't know. But it's the
What we've been doing for literally everything else. It's a little rule. The rule. Hey, is it not e to the 1 over x over x squared?
That's a derivative, isn't it?
It isn't. Wait, is it? Oh my god. That sucks.
Okay, don't mess up derivative and antiderivative. You're doing two separate things here. Okay, so now the next one is a little bit more challenging. So we got 2 more questions to go. We got 9 minutes, so it's perfect. We're doing good. ln of 4 and ln of 2 here. E to the x over 1 plus e to the x dx. Oh, actually, I'll give you 2 plus e to the x. 2 plus e to the x. Now remember, when you have boundary, change the boundary. And just do it in terms of u. It's much efficient on writing. It's also much faster. And also that's what AP exam prefer you to do.
So much.
I know.
Xavier, you complain too much today.
Yeah, I do.
Jesus.
I just thought we'd be hanging out today.
No.
Never practice.
Guys, you guys are gonna have a break. By May 5th, you're not gonna see me ever again.
Why?
After AP exam, I'm gone.
Wait, you don't want to hang out with us this year?
I'm at the spear in the face of earth. School's gonna call me. He's like, "Where's Mr. Ye?" I'll be like, "I don't know."
Next year.
Next year I'll be back. But after AP exam, you're not gonna see me. I'm gone.
That's not fair. We will fill the
Like,
need.
I just don't know where to start.
Counter offer? How do you start?
If I had like,
Think about what you learned from from the last test. It's something to do with last test for this one, and it's U substitution as well.
okay.
The problem is you thinking about you cannot do it. The problem is you gotta think I can do this shit. Oh, sorry. I don't say F word. I say shit. That's not super bad.
Derek, I didn't say anything.
Oh,
Oh yeah, because he wrote.
Oh,
I'm sorry. On his notebook, and I put an apostrophe on the other.
it's so convenient.
Too close. No.
E and natural log are inverse to each other.
Yes.
If E and natural log are directly like a power relationship and there is no gap between, so you gotta be careful with like this. Let's say E to the ln of 3, that's just equal to 3. But it's E to the 2 ln of 3, that's not 3 actually. Because you gotta move the 2 up here. Guys, this is actually pretty important. Shh. E and ln will cancel out. But if it's E to the 2 ln of 3, they're not next to each other. You gotta move the 2 away. So it becomes, actually this becomes 9. Because 2 becomes the power, and then that's gonna become how it works.
Wait, so it's ln of the 9 equals ln of.
So what does U has to be here? Think about it.
2 plus e to the.
Why?
It's not 1.
Why do I set it U equal to there? Why can I set U equal to E to the X?
It doesn't cancel out later.
It doesn't cancel out later, but you want to cancel as many things as possible. You can get rid of 2, that's the best. So that's why I do 2 plus E to the X. And du is equal to what? E to the X dx. Jonathan, pay attention. You don't remember how to do this? You need to know how to do it. No, you don't. No, you don't. No, you don't. Du over E to the X dx. Like I said, you don't know anything. U, not really good.
Sure about that.
Yeah,
I feel very good about it.
Connor did better.
Connor did very well.
Okay, du, so now it's gonna be du over E to the X. Now E to the X gonna cancel out. So now I change that to du over U, but the boundary is still in terms of X. So then I'm gonna sub in there 2 plus E to the ln of 4. This one is gonna cancel out with 6. 2, like 2 plus, right? E to the ln of 2, that's equal to 4. So it'll be 6 to 4, and that's gonna be ln of 6 minus ln of 4. Because that's integration. After that, you can simplify it. So it'll be ln of 3 over 2. So that's my final answer. ln of 3 over 2. What?
Do you not do plus C?
I don't need a plus C because I'm doing defined integral. I'm doing definite integrals.
Oh, never mind. Eliminate 2 plus. But like we already did that.
Very, very gross problem right here. You got 3 minutes. Come on, Derek.
Okay. You know what? I'll put it down. Yeah, no.
You're supposed to perform better at the end of the game. You don't have what? Oh.
You know, let me just say this. It's not that bad. It's incredibly bad. It's always
Xavier, you're whining too much today. You need to stop whining.
I'm so worried about that. Not the one yesterday. The other one.
Wait, which one? Oh, the one you didn't get an A on?
Correct. Correct. By 1 point.
Wow, it hurt so much. It hurt so much.
I can say I've every test on mystery A. I've never gotten less than an A, right?
You never go above a F.
I've gotten a D and C before.
So you got one of those in every class, huh?
Literally sucks.
Okay, so you're fine.
I did the indefinite, bro. I don't think that.
Did you ever find my test paper?
Yeah, I'll look.
Instead of writing the offer,
I know the calculator was four.
yeah. I think special privileges. I think you should have given Katie the one as well.
That was really bad.
Robert. Oh, you got cut off line. It's an A.
You hit the cutoff line. What about me? What did I get on that? Reading radio.
I would hope a lot.
I know, I give it back to you.
Well, I just took it.
So wait, I got an A?
Oh, no, I haven't. I haven't.
Did I got an A or not?
Yeah, I will do correction on it though.
It's the cutoff line. You got it. You got it. You think I 19? Okay.
Thanks for another great training day.
Robert's stopping it.
One you gotta go.
Huh? Sure.
We're still gang right there.
All right, I'm gonna go over this question. So u is equal to secant of 2x.
I got everything right.
U equal to secant of 2x, du equal to secant of 2x times tangent of 2x times 2 dx. So that will cancel out e to the u. The secant and tangent of 2x will cancel out, and left with 1/2 du here eventually. So that's going to be 1/2 e to the u. Now I have to change the boundary. So secant of 2 times pi over 2 is equal to secant of pi. Secant of pi is what? It's -1, right? And secant of 2 pi over 3 is going to give you a -2. And then so it's going to be 1/2 e to the -1 minus e to the -2. Now, if you want to be extra, you can simplify this 1 over e minus 1 over e squared. And that's going to be 1/2 e to the square minus e over e squared. And that's the final answer.
You put 2 pi over 3 is -1, right?
Negative.
What? Yeah, if you put it there on the bottom left, but like on the right. -1.
Okay, let's see.
I get this every Friday. It's a hassle.
Yeah.
I haven't seen you for a while.
What, tutor?
Yeah.
I'm gonna start coming again next week. I'm gonna come Monday through Wednesday.
Okay. Yeah, you need to start coming.
Yeah.
Yeah, man.
You there, John?
I'm here today.
Thanks, dude.